Welcome back. Today we are going to continue in Unit 2. We are going to look at Lesson 2.6. And we're going to look at families of functions. And so this is something that is going to be very important because we will continue to build on this idea throughout all of Algebra 2. So we've seen how to graph an absolute value function if we use a table of values. But today we're going to do the graphing without a table. And we're going to see what happens when we compare a function to its parent function. So the first thing we need to know is what is a parent function. And the parent function is the simplest form of a function, and you can see several examples there. We've been looking specifically at absolute value functions, and so it would be when it's just y equals the absolute value of x. It doesn't have anything added, subtracted, multiplied, or divided, but that would be the parent function for absolute values. And then a translation, you may have heard this term through geometry, but it's a shift of a graph. It can be horizontally, vertically, or both. And the great thing about a translation is that it's keeping the same size and shape. So if I started off with a shape like this, and I want to translate it to the right 4 units, it's going to look exactly the same. It's not going to suddenly change shape, even though that's not perfect. It's not going to suddenly become something that looks like this or like this. It's going to keep the same shape. And so if we graph the parent function, y equals absolute value of x, and then we translate it, the new equation is given by this. Basically, the only difference is that today we're going to look at problems where there is where a is equal to 1. So in this case, b is our horizontal shift and c is our vertical shift. So the b value tells us how far we move left, right, and c is how far we move up or down. And notice that there's a minus sign here. That means that with b, we're always moving it the opposite direction. So if it says -5, we move it right 5. With c, it has a positive, so that means we're keeping the sign. So if it says -5, we're moving it down 5. But we're going to practice this together. All right, so first of all, let's think about the absolute value parent function. The absolute value parent function is going to have a vertex at 0, 0. And then it's just going to look like this. If you want to pause this and double check why this works, you can. But this is a parent function. It's the simplest form of the equation. There's nothing added, subtracted, multiplied, or divided outside of it. So keeping that in mind, if I draw my parent function or sketch it on here, I'm being asked to describe the translation of y equals absolute value of x plus 4. Since this plus 4 is outside of the absolute value bars, that means that we're going to move it up or down, depending on the sign. Since it's a positive, we're going to move it up 4. And then it says to draw the graph. So literally, every point on this graph is going to get moved up 4 units. 1, 2, 3, 4. This point gets moved up 4. 1, 2, 3, 4. And each point is going to move up 4. Another way to think about it is that we are going to start by moving our vertex up 4 units. And then I told you yesterday that we would think of this as our slope, but thinking of this as our slope is the slope of 1, so I would go up 1 over 1, up 1 over 1. And if you don't want to draw the parent function that way, you don't have to. But that's it. I've described my translation and drawn the graph. There's no table involved. So for this one, because I have -2 and it's inside the absolute value bars, this would be moving left or right, and I change the sign. So it would be right 2. So if I want to draw that graph, my vertex started here, and I'm moving everything to the right 2. So now it's going to be over here. And then I still have a slope of 1. Up 1 over 1, up 1 over 1. So really, you've got two different ways you can do a problem like this. You can either draw the parent function or sketch the parent function and for each of these points move it the correct direction. On example 2, I'd be taking this point and moving it right 2 and moving each point right to the right 2. Or you can think about, I'm going to move my vertex. My vertex started at 0, 0, but because I'm moving to the right 2, my vertex is now at 2, 0, and then I can use the slope. So two different ways to do this. All right, describe the translation of this graph, then draw a graph. So first of all, what is the translation of our graph? This 5 is inside the absolute value bar, so I'm going to do the opposite sign and move it left 5. But then this -4 is outside, so it's going to be up or down. Keep the sign so it's down 4. Now, I could sketch the graph of our parent function, just knowing that each side has a slope of either 1 or -1. It changes at the vertex. And then I can move each point left 5, down 4. I'm going to move this point right here, left 5, 1, 2, 3, 4, 5, and down 4, etc. That's going to go like this. Or I can say I'm going to do a slope of 1, so up 1 over 1, up 1 over 1, and then also up 1, back 1, because they have to be opposites. So on the left side of the vertex here, I have a slope of -1, whereas over here I have a slope of +1. It's really up to you how you want to do this. I'm pretty flexible. I will be curious to see which method you like a little bit better. So a few more key terms we need to know are stretch and shrink. Stretch means that m is greater than 1. I don't really have a good way to remember that. And it makes the graph look taller and skinnier. So instead of looking like this, it's going to look like this. That would be a stretch. It's stretching it taller. And a shrink would be going from this to something like this. Oops. Where it makes it look shorter and fatter. It's kind of like we're pushing down on top of it and squashing it, flattening it out. So our translation here would be to move it left 3 because I do the opposite sign, and down 7. Right away I've already defined my translation. So I'm going to move left 3, down 7. The last thing I need to describe is, does it have a stretch or does it have a shrink? If I look at this number 3, and I take the absolute value of it, I get 3. So this would be, it's not bigger than 1 or greater than 1, so it would be a stretch of 3. Now what that means is from my starting point or from my vertex, instead of doing up 1 over 1 like I did on the last few problems, I'm going to go up 3 over 1, up 3 over 1. I'm also going to go up 3 and back 1 because I want to do a slope of -3. Oops. And some people have been asking, how far do I need to draw my arrows? I say it needs to go past the last point that you do, the fourth and fifth points. It should go a bit past that. You don't have to go all the way off the graph right now. Later on we will, and you'll see why. But as long as you put the arrows on the end, you're good. All right, so for this one, looking at the inside, I've got -7, so that's going to be the opposite, and right 7. This one is +5, so the same, so it'll be up 5. So right away I'm going to put my starting point, right 7, up 5. And then I'm looking at this, and my absolute value is just going to be 1/3, which means that it's going to be a shrink. It's going to have a slope of up 1 and over 3, and it's going to go right here-ish, up 1 and back 3. And if I were to sketch the graph, sorry, sometimes I can't draw and talk at the same time. If I were to sketch the graph of the parent function, it would look like this. I can see that the translation has happened. I can also see that the shape is a little bit different. It still has two lines with opposite slopes. They're just, this angle here, if you will, is bigger than this angle, and that's what we want. All right, so what would happen here? What would be the translation of this? Describe the horizontal shift, the vertical shift, and the stretch or shrink. If I look at the inside, I do the opposite sign, so I'd get left 1, and then here I would get down 6. And then remember, I'm taking the absolute value. I want to be very careful because it says a value of m that is greater than 1. Really, I should say an absolute value of m that is greater than 1, because if I had here, if I'd had a slope of -3, it would still be a stretch. It would just change which direction it opened. So here, 2/5, the absolute value of -2/5 is less than 1. So this is going to be a shrink. But it's also, because of this negative right here, it's going to open down. That's kind of the key. When that m is positive, when it's a positive m, it's going to open up. And when it's a negative m, it's going to open down. All right, so we've got left 1, down 6. And that's the starting point. So that's my vertex. If I wanted to write the coordinates, it would look like this. And then I'm going to do a slope of -2/5. So I'm going to go down 2 over 5. Remember that if it's a negative slope, that negative can only go with 1. So I can either do -2 over 5 or 5, but I can't do down to, I'm not supposed to do like down 2 and right 5. Negative and negative. However, that's for the starting one to the right. That's my negative slope. But to get the other side, I do the opposite, and I do a slope of +2/5. Now, positive does not mean that I go up. It can mean that it doesn't only mean I go up. It could mean that I go down here. So 2, and then 5. 1, 2, 3, 4, 5. And you'll know that something's going right if your final shape looks like it's supposed to. I know that it's supposed to be an absolute value function opening down. But if you were to graph it and it for some reason went up like this, or it got wonky and started curving, you would know that something was wrong. So this has been just kind of a introduction to parent functions. And like I said, we're going to see parent functions all the way through the very last unit of Algebra 2. And this is something that's going to become very important. This idea of the coordinate that's with x changing this sign and keeping this sign is not going to go away. It's pretty much going to be that way for almost every type of function that we look at. So if you have questions, please ask them. I would be happy to answer them. And if you need to go back and rewatch any part of this so that you can get a better understanding of parent functions, please do so.